So we're starting off here with an ideal gas calculation, and again, quite a lot of information to go through and process. I'm always going to recommend with ideal gas equations that you start off by taking the data, taking the PV nRT and filling in the data that you have. And you can see from the color coding where I've taken that information from. This systematic route through allows me to see that N is the one that's missing. It also then allows me to sweep back through and decide which of these do I need to change my units. So we need to remember that pressure is in pascals, so I've converted that. We need to remember that volume is measured in meters cubed, so I'm going to convert my cm cubed to meters cubed by dividing by 1,000,000 or multiplying by 10 to the minus 6. I don't need to change the R, and I don't need to change T because that's already in Kelvin. Once I've done that, I can start to put the information into the expression. So I've got my PV is nRT, I'm rearranging it to make N the subject, and I've put all of my data in. Because I've written out the expression and I've then put the figures into the expression, I've now got 2 out of the 5 marks. And I get a third mark for successfully calculating N. I've got 0.0024 moles. Now, we want to know the relative molecular mass. So we're going to use N is M over MR. We're going to rearrange it so that MR is M over N. Now, my mass, again, you can see I've taken it from the table, 0.194. I have remembered to convert my milligrams to grams, another common, easily missed part of the question. That then takes us through to an MR of 82. Now that is to 2 sig figs, which is unusual because normally for an MR it would be 1 decimal place. The question asks for the appropriate number of significant figures, and because the volume was only given to 2 significant figures, our answer cannot be more precise than that. We move on to an empirical formula question. We want to know the empirical formula of Y, which is a hydrocarbon, and we've only been told the percentage by mass of carbon. Going to start out by drawing the table M, MR, N and ratio. MR is technically AR, it's the atomic mass in this case. And we were given 83.7 for carbon, and we know that the atomic mass is 12, so we can put that in. Now, we also know the atomic mass for hydrogen, which is 1, and we can work out the remaining percentage. Because it's a hydrocarbon, we know the remaining mass is all hydrogen. So I've now got 2 masses and 2 atomic masses. I can do my calculations to find N, and I get 6.975, 16.3, and when I work those out to the simplest whole number ratio, I get C3H7. I've now got to 2 marks. The third mark is really straightforward. I actually write out the empirical formula, C3H7. But we also want to know the molecular formula of Y. Now, we're told the molecular mass is 86. If it was C3H7, the molecular mass would be 43, which is exactly half that. So I need double the number of carbons and double the number of hydrogens. So that's precisely what I do. I change my C3 to C6, my H7 to H14, and I have my molecular formula C6H14.